Hello everyone, this is David Collins from Ann Arbor Guitars. This is the fourth video in our series on guitar electronics, where today we're going to start looking at what happens to the tone of your instrument as you roll the volume control back and what we can do to modify that. Now this is kind of limited what we'll be able to show you on the charts. It'll be much more revealing once we start to plug in and you actually can hear the difference. A problem most players are familiar with is that when you turn the volume control down in most guitar and amplifier combinations, you tend to lose a lot of your high end. It starts to get a little bit muddy and muffled. A large part of this is happening because as you turn the volume control down, you are in effect further loading the input of the amplifier. A tube amp that might have a 470K impedance, when you turn down halfway, you are putting a 100K load across that, and you're changing the dynamics of at the amplifier end of the circuit. So what we do oftentimes to correct that is add what's known as a treble bleed circuit. This is simply adding a capacitor or a resistor and a capacitor together across the middle and upper lugs of the volume pot. And what this does is as you turn the volume control down, and separate the coil output from the amplifier input, this helps the trebles still pass more directly through with less separation as you turn the potentiometer down. It's not actually solving the source of the problem, but it is reintroducing more trebles proportionally in the circuit to help rectify it as best we can. Let's start by turning our volume down to around 5. Now, as I said on this spectrum analyzer, we're not really seeing a notable shift in the frequency response because we're not engaged to the amplifier part of the circuit. But you will see as I engage the treble bleeds how they affect the overall treble and response overall, actually. Let's start with one of the simplest, just a single capacitor. In this case, 680 picofarads. Which is a very low value capacitance. And as we turn the treble bleed on, you can see we just got a notable bump in the treble response. The low end stayed pretty much the same, but the treble response, our resonant peak jumped up in amplitude quite significantly. Dropped in frequency a bit, but the overall highs are coming through quite a bit more. For a lot of players, this capacitor alone can simply be too drastic of a treble bleed. It actually tends to make it sound almost a bit brighter as you turn down. Another common solution is to put a capacitor in parallel with a resistor. 0.002 microfarad combined with a 220 kilo ohm resistor is a very common combination used for this. When I turn that on, you see something new happening. Not only did we bring the trebles back up, there's without it, there's with it, we brought up everything in the 1-2K range and up, but we also brought the overall frequency response. Let's look down between 100 and 200 kilohertz, 100 and 200 hertz, and you can see by engaging that, we actually brought the overall response back up. What this does is it actually creates something in between an audio and a linear taper pot. It favors the trebles. As you turn it down, the trebles make it through most of all, but with that resistor added in parallel with it, we're also letting an overall more of the signal through, and it effectively changes the taper. Let's compare at 5 with this treble bleed scenario to at 5 on a linear. And you can see, by adding that treble bleed, we've come quite a bit closer to replicating a linear taper in the upper portion. The beauty of this treble bleed circuit is, as we get to the very bottom, we still retain that smooth fade out that an audio pot offers as compared to the more abrupt fade you find in a linear pot. Now there are a number of different combinations. You can move the capacitance and the resistance value up and down, and sometimes it just takes a little bit of experimenting to figure out what works best with your pickups, your amplifier, your playing style. Here's the 220K resistor with the 0.02 we were just looking at. Let's shift that to a 150K resistor and a 0.001 microfarad capacitor. And you can see it is a little bit different in the overall amplitude, the overall response, and the frequencies that are most accented. With the 0.001 limiting the high frequencies a little bit further up the spectrum in, as far as what it accentuates, and the 150K resistor actually letting the overall signal through a little bit more readily, so it comes even closer to a linear taper potentiometer roll-off. One of my personal favorites is to put a capacitor and a resistor in series together. This doesn't change the taper quite as much, but does a good job of balancing the highs without overemphasizing them as much as the capacitor alone. And here we have the 0.001, the same two components, 0.001 microfarad capacitor with a 150K resistor. Here they are in parallel where we get the overall signal boost, and here they are in series where it doesn't change the taper as much, doesn't boost the signal as we roll back, but you can see this lower end, most of the lower half of the signal stays fairly consistent, but we do get a notable boost up there in the 2K and up range. So let's go ahead and have a listen and see what they sound like. Okay, for the treble bleed circuit, let's for now let's use, say, 250K pots and single coil pickups. Let's go ahead and use it in the middle position. And you can see a lot of that high end is rolled off there as we roll back about halfway, audio taper volume. But now let's engage the single capacitor, 680 picofarads. See, it actually adds more brilliance and brightness than there is when the volume's on 10. Some people may like that, others not so much. Let's shift down to the much more modest 0.001 microfarad cap, higher value cap. Gives a little more modest accent to the extreme high end. Spreads it down a little lower into the frequency range. And 150K resistor in series. See, still a big difference, but not as focused on the extreme high range as the 680. Now put that same resistor and capacitor in series, and here's what you get. You get a much more noticeable boost to the overall volume because you are, in effect, by putting that resistor in there straight from one lug to the other in a parallel arrangement here, you're changing the taper of the volume pot as you roll back. So there's no treble bleed. There's a cap and resistor in parallel. And here's a little bit more modest version, 0.002 cap with a 220K, not as drastic a drop resistor. So you can see the 002 220 puts a little more focus on the high end, a little less boost to the volume overall. The 001 150 brings up the overall volume without as much focus on the high end. And the series arrangement, more modest yet. Really just bringing some of the high end back without too much change in the overall signal. And cap on its own is typically going to be the most bright, especially when you get into extreme low level caps. Let's move this into another environment though and kick it into overdrive, where we may want a that cleanup as we roll the volume down. But when we get clean, we don't want it to get muddy as well. And that's when one of these treble bleeds can really come in handy, is being able to clean up your tone and get a nice, crisp, truly clean sound with a good high-end response. As you roll your volume back, rather than the typical muted highs we're all familiar with. So again, this is certainly one area of the wiring where there is no definitive absolute answer. Some people prefer no treble bleed at all. It's not often used with linear pots because of the way it can affect the taper and slow them down even more as you roll off, which is not a quality most people desire from linear pots. But with an audio pot, there is a near endless combination of capacitors and resistors you can try. Some may work better with some pickups and amplifiers than others. Something you'll just have to go and experiment with if you really want to fine-tune your own setup. Please stay tuned for our next video where we're going to start looking at another approach to retaining some of the high end as you roll your volume back, often referred to as 50s wiring, due to the fact that Gibson wired their tone and volume controls together in this manner in the 1950s. But we'll get more into that in our next video. Thanks so much for watching, and we'll see you soon.